This is what you and I know as a Cavendish banana, and this is what we know as a carrot. What if I were to tell you that just 500 years ago, neither of these plants actually existed? In fact, if you wind the clock back 10,000 years, not a single fruit or vegetable as you know them even existed at all. So if we were meant to eat fruits and vegetables, what exactly were we eating when we didn't have them? Well, in this video, we're going to look at a story that no one talks about. How the foods we think of as natural have slowly become something very different to what they originally were. And more importantly, we'll look at how these changes are affecting your health today. To understand how we created all of these fruits and vegetables we eat nowadays, we must head back in time to get the full story. From almost as far back as human history is known, up until around 12,000 years ago, humans lived in the Ice Age. As the name suggests, the Ice Age was a time where most of the Earth was either completely covered or at least heavily impacted by ice and icy conditions. Because of the ice, it was very difficult to grow crops or to put up fences to farm livestock. You also couldn't eat many wild plants. Most were covered by ice, too toxic to eat, or were only around very seasonally for 1 to 4 weeks per year. So us humans, we became the ultimate hunter. The apex predator of all apex predators. In fact, we can see this demonstrated clearly in our fossil record. In fossils, there is a tropic marker called nitrogen-15. This is used to determine exactly where an animal sat on the food chain. Put simply, the more nitrogen-15 found in a fossil, the higher that animal sat on the food chain. Every human fossil ever found from 12,000 years ago and prior shows humans were at the very top of the food chain, above every other animal, including wolves, tigers, lions, you name it. Our preferred food was large megafauna animals, which surprisingly, due to our advanced hunting strategies, were very accessible for us to hunt. However, around 12,000 years ago, the temperature of the Earth rose sharply. So the vast majority of this ice, it melted. This right here changed everything. Firstly, many animals went extinct. In North America alone, around 12,000 years ago, at least 60 species of large mammals went extinct. Now, the exact cause of this extinction is still debated. Some scientists believe it was mainly due to rapid climate warming at the end of the Ice Age, which transformed large ecosystems too quickly for large animals to adapt to, whereas others argue it was human overhunting, and that as humans spread across new continents with advanced tools, they overhunted slow reproducing megafauna all the way to extinction. Most likely it was a combination of both, but we humans now had a massive problem. Our main food source was completely gone. Luckily, however, the melting of the ice now meant we had access to the previously covered landscape, so we put up fences and kept smaller animals who hadn't died off, in order for their milk and eventually their meat. However, while domesticating animals certainly helped, it simply wasn't enough. The large game that had vanished, and these smaller animals couldn't feed our rapidly growing populations on their own. With more people to feed, we needed a large steady food supply. So we turned to the land itself. The melting of the ice exposed fertile soil that had been locked beneath glaciers for thousands of years. This new rich ground could grow plants. This was the beginning of a new era, but there was just one major problem. In order to survive, we humans desperately needed this large, steady food source. Now, the obvious solution would be to start growing crops. Animals take years to develop to a good size, and once they are no longer living, they go bad and expire, as we'd call it nowadays, very quickly. But plants grow much quicker, and they last a lot longer before they go off. So the obvious solution would be to start growing crops, then during their once per year harvest, store them until we want to eat them. If only it were that simple. At the time, like there is nowadays, there were hundreds of thousands of different species of plants, but they all shared one major problem. They were terrible food sources, and this was for a number of reasons. Firstly, they were very toxic. You see, plants don't want to be eaten, but they can't defend themselves through physical capability like animals can. So in every single plant, there is a long list of toxic compounds that the plant uses to deter and poison attackers. This meant we couldn't eat most plants, and the ones we could eat had to be eaten in only small quantities to prevent us from being poisoned to death. The second issue these plants had was extreme bitterness. When something has expired and smells bad, your nose detects this and you smell an unpleasant smell. Well, our taste buds work in the exact same way. When your taste buds are exposed to toxins, they identify this and you taste an unpleasant taste. Because every plant was very high in toxins, they all tasted incredibly bitter and just terrible in general. And the third major problem with these plants was that they were very small and did not provide us with enough energy in order to survive. For example, what we call corn nowadays look like this. As you can see, that's not feeding many people. What we call wheat nowadays look like this. Exact same issue. And what we now call potatoes, well, they were only 1 to 2 centimeters in size. They were tiny, fibrous, and far more toxic and therefore bitter than they are today. So how on earth did we solve this massive issue of all plants being a terrible food source? How did we go from plants that look like this to plants that look like this? Well, we came up with something that would completely change the entire course of human history. We came up with two very clever methods that essentially allowed us to rewire nature. Times were getting desperate. With growing populations to feed, something had to be done. Luckily, desperation drives innovation. Early farmers began to notice subtle patterns. When they planted the seeds from the plants that were the biggest and healthiest plants from their crop, the next generation of crops tended to be larger too. They also noticed that this was true with other desirable traits also. When they replanted from plants that tasted sweeter or were less bitter, those same traits became stronger over time. This was the discovery of what is known as selective breeding. Humans realized they could choose which plants reproduced, and by doing so we could shape the entire species of a plant. So this is what we did. Generation after generation, we would only replant the seeds from the plants that were the largest, sweetest, and least bitter. This way we had more total volume of food to eat, but because we were breeding them to be less toxic, we could also eat more of them. Now, this selective breeding method explains how we eventually turned potatoes from 1 to 2 centimeters in size and highly toxic, into 10 to 15 centimeters in size and far less toxic, and how we turned small, hard, and edible wild corn into massive sweet corn that we eat today. But what selective breeding doesn't explain is how we created completely new plants. Broccoli, cauliflower, kale, cabbage, and basically every other vegetable weren't just selectively bred and transformed into a plant that looked unrecognizable from its original natural form. No. These plants were essentially man-made. We engineered them. So, how did we do this? Well, it likely started with a simple observation. When two slightly different plants grew close together, sometimes their offspring looked a bit different. It looked like it combined traits from both parents. One might have the thick stem of one plant, but the large leaves of another. Sometimes it may look like one plant, but due to this hybridization, it was larger, sweeter, or just tasted completely different. At first, this would happen by accident. Wind, insects, or proximity would carry pollen from one plant to another. But we humans, we picked up on this. And once we realized we could control which plants mix, we began to do it intentionally. This was the discovery of something called crossbreeding, which is where you intentionally grow two similar plants next to each other and allow them to cross-pollinate. This combines genetic traits of each and as a result creates new plants. In fact, broccoli, cauliflower, cabbage, kale, and Brussels sprouts all came from a single wild plant. They all have the same common ancestor, the ancient wild mustard. By selectively breeding different parts of it, the leaves, stems, or flower buds, humans created an entire family of completely new vegetables. Now obviously we didn't call them that back then. The word vegetable wasn't invented until around the 15th century. But that right there is how we created what we now call vegetables. In fact, it is through both selective breeding and crossbreeding that humans have created every single plant that we currently eat. Bananas were created in Southeast Asia around 7,000 years ago by crossbreeding two wild species. Even to this day, we're still making new variations of the banana. The Cavendish banana, the one we all know about, that was only created in 1834. The original bananas were small, full of seeds and not very sweet, but we have selectively bred them to be soft, seedless, and packed with sugar. Apples were created in Central Asia around 4,000 years ago by crossbreeding wild cranberries to produce a larger, sweeter fruit. These original apples were tiny, sour, and hard, but we have selectively bred them to be big, juicy, and sugary. Broccoli was created in Italy around 2,000 years ago from the wild cabbage plant through selective breeding. It was bred to emphasize the flower head, which was originally small and tough, but we've turned it into the large, tender vegetable that we know today. Carrots were created in Persia, which in the modern day we know as Iran and Afghanistan, around 1,000 years ago, from thin, bitter wild roots. These original carrots were small and typically purple or white, but we have selectively bred them over time to be thick, orange, and sweet. In fact, just 500 years ago, carrots were still purple. Oranges were created in China around 500 years ago by crossbreeding pomelos and mandarins to create the sweet citrus that we know today. These original fruits were large, dry, and sour, but we've selectively bred them to be juicy, soft, and high in sugar. But perhaps the most staggering example of this is actually watermelons. Watermelons were created in Africa thousands of years ago, from small, hard, and pale wild melons that contained very little flesh and almost no sweetness. Through centuries of crossbreeding and selective breeding, humans turned them into the massive, sugar-packed fruit that we know today. Interestingly, ancient watermelons were about 20 times smaller and contained roughly 20 times less sugar than they do nowadays. That means that today's watermelons have around 400 times more sugar than their original wild counterparts. What was once a tough, mildly bitter fruit, used mostly for hydration, has been turned into a dessert-like food, made almost entirely of sugar and water. Now this may all look wonderful, a true story of human mastery that has allowed us to create a stable food source, which in turn allowed us to propel our species forward. And in a sense, it's true. If we had not solved this massive issue of not having enough food, we could never have created the beautiful civilizations that we have nowadays, with skyscrapers, technology, and global cities. This invention of agriculture, the creation of fruits, vegetables, and all other plants that we currently eat, has not only been beneficial, it has caused some serious issues, to the point where some people actually refer to it as the greatest mistake our species has ever made. Before agriculture, we knew food was scarce. In fact, humans were so desperate for food, we made ourselves sick for thousands of years just to consume enough energy. We know this because in order to absorb milk properly without getting sick, a person must have a genetic mutation called lactase persistence. This mutation is responsible for the ability to keep producing the enzyme that breaks down lactose, the primary sugar in milk, into adulthood. Now, archaeologists have found traces of milk fats on ancient pottery dating back at least 9,000 years ago, which confirms we've been consuming dairy as far back as then, although it's probably even further back than that. But this genetic mutation of lactase persistence does not appear anywhere in human fossils before 7,000 to 8,000 years ago. This means that for at least 1,000 to 2,000 years, humans were drinking milk that made them bloated, nauseous, and sick, but they kept doing it anyway. We were willing to suffer immensely just to survive. We had hoped that by creating these fruits, vegetables, and grains, it would solve our food scarcity issues and allow us a stable food source that not only sustained our growing population, but also kept us healthy. Now, we got one part of the equation right. We indeed did create enough food. But the second part of that equation, well, we could not have been more wrong about it. Almost immediately after the agricultural revolution, the human body began to deteriorate, very rapidly in fact. Fossils show this very clearly. The average height dropped by around 3 inches in both men and women. Skeletons pre-agriculture are virtually free from lesions and markings on them. Lesions and markings indicate infection and disease. This indicates that on their carnivorous diets, these humans pre-agriculture were very healthy. But in all post-agriculture fossils, many lesions and bone markings are heavily present. Our dental health also collapsed. Before agriculture, humans had straight, strong teeth with almost no decay. After the switch to crops, cavities, enamel defects, and crowded jaws became widespread. The very structure of our skulls changed, showing weaker jaws and narrower faces. And perhaps the most shocking change of all, our brains, they shrank. Since the beginning of agriculture, the human brain size has decreased by roughly 11%. This is likely due to the fact that key nutrients that build and maintain brain tissue, such as vitamin B12, DHA, carnitine, and choline, all come from animal foods. A perfect illustration of all of this is an archaeological site called Dixon Mounds in Illinois. Over 1,000 human fossils have been discovered. At this site, it captures the exact moment humans shifted from a meat-based diet to agriculture. Before agriculture, the fossils show tall, strong humans with no lesions or bone markings. Their teeth were straight, jaws wide, and cavities were rare. But just a soil layer above, our nitrogen-15 ratings, that marker that indicates how carnivorous a species is, how much meat a species eats, it decreased considerably. This marked the exact moment when we switched to eating crops. These post-agricultural fossils are 3 inches shorter, show infections and bone degeneration. The teeth are crowded, weak, and decayed. And this was not a one-off occurrence. Anthropologist Stanley J. Ulasek described it best. When populations turned to agriculture, regardless of their location or crops, height and health declined. So, yes, we solved our food supply issue by creating much larger and less bitter plants than what was available in nature. But we traded our strength, our stature, our health, and even our intelligence for it. Within a few thousand years, humans went from tall, robust apex predators to shorter, weaker, and as a species far less healthy. Many people have the idea that as long as we eat whole, unprocessed foods like fruits, vegetables, and grains, everyone will be incredibly healthy. But here's the thing, science, time and time again, across every single species, shows that this is not the case. There is a very well-known concept in the field of biology called a species-appropriate diet. The concept states that a species must eat what it's always eaten or it becomes very sick. This is very established. Veterinary pathology shows that when an animal is left alone in the wild, and eats the same thing it has always eaten, it is typically very healthy. But when we change what it eats, even very slightly, it becomes obese, diabetic, and very sick. For example, in this study here, they fed rats a high-fat, high-sugar diet. Instead of their typical diet consisting of grains, seeds, and small insects, the rats became obese, diabetic, and prone to metabolic disease. In this study here, they fed Degus, which are another type of rodent, sweet fruits and sugary lab chow, instead of their typical diet consisting of fibrous desert plants with almost no sugar. The Degus rapidly developed obesity, diabetes, and other metabolic disorders. In this study here, they fed cows a grain-heavy feedlot diet, instead of their typical diet consisting of grass and roughage. The cows developed stomach acid buildup, infections, and sore, damaged feet. The concept of a species-appropriate diet rings true every single time, without exception, even simply with herbivorous species when they consume a plant they have not evolved to eat. But it gets worse when a carnivorous animal, who has evolved to eat meat, eats a plant it is not used to eating. In this study here, they fed farmed Atlantic and Chinook salmon a soybean meal diet. Salmon in the wild are a naturally carnivorous animal. They typically eat krill and shrimp. The salmon developed intestinal inflammation and poor growth, with severity depending on diet level, temperature, and life stage. Unfortunately, we are seeing this play out with our pets also, who we are feeding grain-based kibble to instead of meat like they would typically eat in the wild. In fact, in recent times, the average lifespan of a golden retriever has decreased from 17 years in the 1970s to just 10 years today. But perhaps the most striking example of this is seen in pandas. Pandas come from a carnivorous ancestor. However, approximately 6 to 7 million years ago, they started to eat bamboo, likely due to the fact that they were not efficient enough at hunting to have a continuous source of meat. And despite millions of years since that shift, they still haven't evolved to effectively live on their new diet. Like humans, they still have the digestive system of a carnivore, with a poor ability to ferment plants and extract energy from them. So pandas, they spend up to 12 hours a day eating just to stay alive. They also digest only about 20% of what they consume, and poop over 40 times daily. As a result, they live in isolation, and live for 99% of the year 2 miles away from each other, just so there's enough bamboo for each to survive. Their fertility window also only lasts just 2 to 7 days per year. They barely ever mate successfully, and often abandon one twin cub if 2 are born, simply because they don't have the energy or ability to care for more than one. Their nutrient-poor bamboo diet leaves mothers so drained that raising 2 cubs would almost guarantee both would die. So they instinctively choose one and let the other perish. When an animal has evolved eating a certain plant, they typically have methods that allow them to extract nutrients that would otherwise be unavailable, or even synthesize essential nutrients internally if the plant doesn't provide it itself. But pandas, they still haven't evolved this. Their brains don't function properly due to malnutrition and the lack of nutrients. They act disorientated, fall out of trees constantly, and often cover themselves in horse poop for no clear reason. All of these different examples featuring different species clearly demonstrate exactly how important a species-appropriate diet is. Now, regardless as to your belief on whether fruits and vegetables are good for us or not, here are some objective, undeniable truths. Firstly, for most of human existence, we ate close to exclusively meat, as seen in our fossil record. Secondly, every single plant we consume has been created or at least heavily modified by us. And finally, our physiology has not had a chance to adapt. We have essentially zero mechanism that is able to effectively neutralize plant defense compounds, which makes the toxins in plants problematic for us, as well as other components such as the very high carbohydrate/sugar content, which our bodies are simply not used to. We know too much sugar in our body is problematic. Excess sugar fuses with our cells and results in something called glycation, which is an incredibly inflammatory process. Now imagine how the human body, which evolved without exposure to such foods, is supposed to handle something like a watermelon containing 400 times more sugar than it naturally would. So if we have primarily eaten meat for most of our existence, we have not adapted to consuming plants, and we had to create all the plants that we currently eat. Why would consuming plants be optimal for us as a species? The only somewhat credible counter-argument I see to this is that humans have also selectively bred animals such as cows. We have bred cows to be much larger than they quote naturally would be. But there are some key differences with this. When it comes to animals, we've only selectively bred them for size and productivity, not to turn them into something completely unrecognizable from their natural selves. A cow is still a cow, with the same nutrients, compounds, and tissues as a whole that we've always eaten. It's simply just a bigger animal. We've always eaten meat and our bodies are perfectly adapted to digest it. On top of this, because animals defend themselves through physical capability, they also don't contain natural defense toxins like plants do. So there's no new chemical burden placed on our system by the creation of new harmful foreign compounds during this process. Plants, however, are a completely different story. Through centuries and centuries of crossbreeding and hybridization, we've created entire new species, often thousands of genetic steps removed from their original wild counterparts. These modern plants that people now eat contain foreign compounds our bodies were never designed to handle, many of which act as natural toxins or irritants, and even their original, unmodified versions were never ideal for human digestion or nutrition. So while selectively bred animals remain the same food source we've evolved to eat, selectively bred plants have become something entirely foreign to human biology. Now, whenever I make these arguments against the consumption of fruits and vegetables, and instead suggest eating our species-appropriate diet of a carnivore diet, I always get the same response. And that is, well, why is it that the science clearly shows that the people who eat the most vegetables and fruits are the healthiest? And what about the plant-based blue zones, which are the regions of the world where people supposedly live the longest? How do you explain that? Well, put simply, none of it's true. The science definitely does not show that fruits, vegetables, or plants of any kind are part of the optimal diet for humans. It's all a lie, a complete fugazi, some would say. And in this video right here, I break all of that down. Anyway, as always, great speaking with you, and I'll see you next time.